than m, then f of n must be alternative less than f of n. Okay, now we claim that because of this result we have the fact that f is also 1 to 1. We have already proved it's onto. Now we have the fact that it's 1 to 1. A consequence of this is that f is injective. Injectivity means one-to-oneness. F is injective. How exactly does it follow from here that f is injective? That I leave to you. You have to show this. If you have n and m in n, then for injectivity either you show this or you show its contrapositive, that is fn equal to fm implies n is equal to m. I leave to you to show that using this result that we have proved now using induction, one can conclude that f is injective. But we have not just done this result or proved this result just for the sake of making this conclusion that f is injective, because this is stronger than injectivity. This is actually telling us that f is an order preserving map. We will see what those things are later when the time comes, but we have done this thing to complete our solution, because you see we are not done yet. What did we have to prove? We had a natural number and an alternative natural number, and we managed to prove this towards the beginning of the solution, that if n is equal to, f of n is equal to n prime, then that implies f of n plus plus is equal to this. Now we want to show that the converse is also true, and there we will use this result. Finally, let n be a natural number and n prime be an alternative natural number such that this is equal to this. We have to prove that n is equal to f of n prime is equal to f of n. Suppose that is not true. N prime is not equal to f of n. Then by the alternative version of the law of trichotomy, recall that there was something known as the law of trichotomy for natural numbers, which says that if we have two natural numbers n and m, then exactly one of these three things will happen. Either n is less than m, or n is equal to m, or m is less than n. So since we are assuming that these two alternative natural numbers are not equal, so according to that alternative version of the trichotomy law, which is true because both the systems have identical results, either this is alternative less than this or this is alternative less than this. we have either n prime less than f of n or f of n less than n prime. From these inequalities, I keep inequalities within quotes because these are not ordinary inequalities. We have alternative inequalities, if you want you can call them. From these inequalities and what we have proved above, we get either this thing n plus plus is less than f of n plus plus, which is nothing but f of n plus plus, or f of n plus plus, which is equal to fn plus plus, this is less than n prime plus plus prime. By what we have proved above means that result, that order preserving nature of f, that result. If this is less than this, then their successors also have that same order relation between themselves in the order. This will be alternative order relation. But these two things then again contradict our hypothesis that these two are equal. These contradict the alternative version. I can't remember the theorem or lemma, whatever it was, its number, so I had to use the actual name. Of the law of trichotomy or trichotomy, whatever you may call it, trichotomy, because of our hypothesis f of n plus plus is actually equal to the successor, alternative successor of n prime. These are, however, exactly they are saying that these two things are not equal, so that is the contradiction. So our supposition is wrong. That is, we must have these two also to be equal. N prime is equal to f of n. We have thus shown and this completes the solution. We have not only shown that f of 0 equals 0, but we have also shown that this condition is true, that if two elements correspond in the two different systems, then their successors also correspond, and conversely, this converse also we have shown. Further, one more thing we have shown is that f is bijective. So such functions are called structure preserving maps or isomorphisms. Okay. Structure preserving maps generally are called morphism. This is a term from algebra, but the ones which preserve everything, structure as well as cardinality, they are called structure preserving isomorphisms. So if you are familiar with that terminology, then that is okay. Otherwise, don't worry about it. We will see more of that in algebra. So here the section 3.5 ends. After this we have section 3.6. There the chapter itself ends. That 3.6 is on finite sets. Okay, finite sets also have a theory where we define finiteness. We actually define finite sets and we prove their various properties. It's needed, we will do that. But having finished this section, we will now go back to algebra and we will carry on our usual ring theory. But in the next video we will start group theory. Okay, so with that I end this video. If you are new to my channel, please subscribe. So this is me, Lucifer, from a mathematical room, signing off for today. Have a nice day.